Okay, so in continuation of my previous lectures, in which I introduced the formulations of Newtonian mechanics, I gave you a few problems to solve using Newtonian mechanics and the concepts of Newtonian mechanics. Have you solved those questions? I gave you 3 questions, easy questions. Have you solved them? One was the disk rolling down an inclined plane, another was the pulley system, and the last one was a rod which is rotating with a constant angular velocity. Have you tried solving them, and did you achieve any success?
Sir,
Haji.
sir, disk rolling down plane, acceleration was 2 by 3 g sine theta.
All right, good, that's correct. और बाकी दोनों किया था?
सर Atwood मशीन में A पार्ट में सर acceleration m1 minus m2 g divided by m1
प्लस m2, ठीक है, that's correct. और B पार्ट में?
सर B पार्ट में m1 minus m2 g divided by m1 plus mp by 2
प्लस m2 भी तो है वहाँ पे. नीचे m1 प्लस m2 प्लस mp अपॉन 2 है ना. And what about the third question?
सर थर्ड नहीं किया.
Okay, ठीक है दीपक, वेरी गुड. द फर्स्ट 2 क्वेश्चंस आर करेक्ट. नीचे डिनोमिनेटर में m1 प्लस m2 प्लस mp अपॉन 2 होना चाहिए, ठीक है. तो आज जो है लेट अस डिस्कस दीज प्रॉब्लम्स. मैं प्रॉबेबली नेक्स्ट लेक्चर से नेक्स्ट नहीं, ये 3 प्रॉब्लम और एक प्रॉब्लम है चार्ज पार्टिकल इन इलेक्ट्रिक एंड मैग्नेटिक फील्ड्स. That is a little bit of a lengthy problem, so maybe uska half part I'll be able to do today. So we'll discuss these problems using the concepts of Newtonian mechanics that we already know, and then once these 4 problems are done with, we will start with the Lagrangian formulations properly. The entire reason that I'm doing these questions is just for the sake of a little bit of a revision कि Newtonian mechanics में किस तरह के concepts हम use करते थे, and just to do problem solving so that जब हम Lagrangian में जाएं we can see the distinction and we can appreciate what is the difference there. Problems becomes easier, problems becomes difficult, वगैरह वगैरह, whatever it happens, ठीक है. So let us tackle these problems one by one. Deepak has given me the correct answer, but still for the sake of the rest of you, let me try to do them one by one. Okay. The first problem was related to a disk which is rolling down an inclined plane. A uniform disk or a wheel of radius r and mass m rolls without slipping down an inclined plane, and the angle of inclination of that plane is theta. Find its acceleration along the plane. If you are able to find the acceleration, then automatically you will be able to find velocity at a given point in time. You will be able to find distance covered in a given point in time. You will be able to find kinetic energy, etc., etc. All right. So the challenge is to find the acceleration. Now, जो पहले क्वेश्चन हमने लास्ट टाइम किया था, that was a question related to sliding motion. It was just translation. यहाँ पे there are 2 kinds of motion that is happening. One is the rolling motion that is happening, and as a result of rolling, a translation is happening. That is moving, it is moving in a straight line, all right. So इसको करने के लिए again in the Newtonian approach, what do we do? In the Newtonian approach, we take a look at the forces that are involved, and we apply the Newton's second law, and maybe rotation अगर है तो rotation से associated जो relationships है, we use those to come up with the answer. So the first question is, what are the forces that are involved in this problem? What are the forces that are involved in this problem? Yes. What is the most obvious force that is involved in this question?
Torque.
Torque is the result of a force. So it is the result of which force? Torque is a moment of a force. कोई भी फोर्स अगर किसी भी ओरिजिन के रेस्पेक्ट में अप्लाई होता है तो उसका जो रोटेशनल इफेक्ट जिसको मोमेंट ऑफ फोर्स बोलते हैं उसको टॉर्क बोलते हैं. सो विच इज़ द फोर्स दैट इज क्रिएटिंग टॉर्क? And just tell me all the forces that are involved or could possibly be involved.
Gravity.
Gravity is one force, yes, very good. So
And
the most
the other is
the other is
friction.
friction, very good, very good. So the first force is the gravitational force mg, which acts directly downwards. Now because the object is constrained, okay, the object cannot go inside this plane, right? The object cannot penetrate this plane. So object is restricted by this particular plane. So therefore this gravitational force, even though it is acting downwards, the disk is not going to travel downwards in a straight line. Because of the constraint of the inclined plane, it is only going to go along the direction of the inclined plane. Therefore we need to find the component of the force along the inclined plane. What is the component of the force along the inclined plane? It is mg sine theta. If you look here, that if this is the y-axis, let's suppose, all right, and this is the x-axis, okay, so this is y, let's suppose, and this is the x-axis. X-axis is the direction which is parallel to the inclined plane, y-axis is the direction which is perpendicular to the inclined plane, and theta is this. If this is theta, then this is 90 minus theta, right? This is 90 minus theta. Yes, so what is this? This is nothing but mg cos 90 minus theta, right? So if it is mg cos 90 minus theta is nothing but mg sin theta. Similarly, the component which is acting opposite or opposite to the perpendicular direction of the inclined plane, so in a negative y-axis, is going to be mg cos theta. So these are just components of the force along two perpendicular directions, because the force is not along the x or y axis. So along x and y axis, I just found out the forces to be mg sin theta and mg cos theta in a negative y axis. All right. Next, as he has said that another force is there. The force is known as friction. Okay, the friction is basically acting at this particular point. All right, there's a friction here. So whenever you have some kind of a disc or a wheel or a cylinder or any kind of a object that is rolling on any kind of a surface, then the rolling motion is associated, as well as sliding motion is associated with friction. So sliding motion is associated with sliding friction, rolling motion is associated with the rolling friction. That is how rolling happens. All right, so if you look at any kind of a, let's suppose, a disc, then if you look at what happens to, so if the disk is rotating, then there is only one point of contact for the disk, right? This is the point of contact. This is the point of contact for the disk. Now it is this, at this particular point of contact, that the friction is going to occur. Now what is the friction going to prevent? The friction is going to prevent from the wheel from slipping. Okay, the friction is going to prevent slipping. If the surface is completely smooth, then there is going to be no friction. Then the ball will just slip. It will rotate and slip. मतलब surface के ऊपर it will roll and slip. It will not move forward. But friction creates or prevents slipping. So as it prevents slipping, it creates a force, and it is because of this force with respect to which this rotation ends up happening in the first place. All right. So this friction is acting in a direction that leads to the rotation, and this leads to the creation of a torque, and this torque leads to whatever the rotation that is happening. All right, so two forces, the friction and this. So let's do the calculations using the Newtonian approach. Newtonian approach में क्या होता है? And of course there is the reaction force N. All right, there is the reaction force N. Now as I said in the last class, in the Newtonian approach, if there is no motion along an axis, that means forces are always balanced. If there is motion along the axis, that means forces are imbalanced. So if you look along y-axis, then of course the forces are balanced, right? Y-axis में क्या है? N is equal to mg cos theta. How do we know? Because there is no motion along the y-axis. वाई एक्सिस को मैंने परपेंडिकुलर टू द प्लेन रखा है, एंड परपेंडिकुलर टू द प्लेन देयर इज नो मोशन दैट इज हैपनिंग. So that means whatever forces are there along the y-axis are all balanced. N is equal to mg cos theta. However, along the x-axis, forces are not balanced because there is motion that is happening. And for motion to happen, there must be a net force. And it is a net force that leads to some kind of an acceleration. So whatever is the acceleration A is being created by some kind of a imbalanced force or a net force. Okay? That is the Newton's second law. That if acceleration is being created in an inertial frame of reference, again I am assuming that this is an inertial frame of reference, it is not experiencing any acceleration from the outside. In that particular case, the forces which are imbalanced along the x-axis will lead to some kind of an acceleration. What are the forces along the x-axis? The forces along the x-axis are nothing but mg sine theta minus f is equal to ma. Alright, mg sine theta minus f is equal to ma. This is the equation of motion along the x-axis. Now the question is, I just now told you that it is because of this particular friction that this rotation without slipping is happening. Alright, so how is the friction and the rotation related to one another? What is the role of the friction and the rotation? Can anyone tell me? How is friction and some physical quantity of rotation related to one another?
Sir, FR equal I alpha.
Yes, very good. So यहाँ पे क्या हो रहा है, जैसे कि स्टार्टिंग में हर्षिता said that there is a torque involved. Okay, so what is torque? Torque is the force responsible for causing rotation. Now what is torque? What is the formula for torque, beta? With respect to, let's suppose, the center of the disk. What is the formula for torque? R cross F, right? R cross F, right? Torque is R cross F. यहाँ पे R और F perpendicular है ना?
Yes sir, yes sir.
So that means torque can be written as RF sine 90 degrees. That simply means that it is RF. Okay. Now जिस तरह से फोर्स को लिखने के लिए हम लिख सकते हैं फोर्स इज इक्वल टू मास टाइम्स एक्सेलरेशन, फोर्स इज ऑल्सो रिटन एज वेरियस अदर dp upon dt. तो टॉर्क कैन ऑल्सो बी रिटन एज, टॉर्क ऑल्सो हैज अनदर एक्सप्रेशन, and that expression is known as moment of inertia times the angular acceleration that is being caused. Yes, this is one expression for the torque in terms of the force and the distance of that point where the force is acting perpendicular with respect to the origin of the disk, and in terms of moment of inertia times acceleration. Yes, these two are valid expressions for the torque. Yes or no?
Yes, sir.
Yes,
Yeah.
sir.
So that means this disk is experiencing some kind of an angular acceleration, and it is also experiencing some kind of a linear acceleration, right? The linear acceleration is related to its linear motion of the center, and the angular acceleration just tells us about the change in the orientation of this disk with respect to the origin of the disk. So here alpha here represents the angular acceleration, and I here represents the moment of inertia. Now I am saying disk over and over again. What is the moment of inertia of a disk? What is the moment of inertia of a disk?
Sir, about axis perpendicular to it, mr square.
Yes, about an axis perpendicular to the disk and with respect to the center of this disk, जिसके respect में हम motion को study कर रहे हैं, rotation को study करते हैं. Half mr square, yes. Half mr square alpha. Okay, so this gives us an idea about what is friction. So friction is equal to r gets cancelled, half m r alpha. Okay, this gives us an idea about half m the relationship for friction. So now I have something to put here. Okay, I can put this here. I can put this here. Yes. However, I also want to find out the acceleration. Okay, I want to find out what is the acceleration ठीक है. I am not interested in finding out what is the angular acceleration. I want to find out what is the linear acceleration. Now can anyone tell me what is the relationship between the linear acceleration and the angular acceleration? Relationship between the linear acceleration and the angular acceleration.
Alpha is equal to A upon R.
Very good. Alpha is equal to A upon R. This comes from this particular condition, without slipping. हमने यहाँ पे क्या बताया था? Without slipping. The motion is happening without slipping. So if the motion is happening without slipping, then any kind of a problem where you do rotation, where without slipping condition is given to you, then automatically your mind should go to the relationship that V is equal to R omega. तो V मतलब क्या होता है? अगर ये ऑब्जेक्ट जो है किसी ओमेगा एंगुलर वेलोसिटी के साथ है और इसका जो है कोई रेडियस है R, तो इसकी जो ट्रांसलेशनल वेलोसिटी होगी, इट इज़ जस्ट गोइंग टू बी V. सो V इज इक्वल टू R ओमेगा जस्ट गिव्स यू एन आइडिया अबाउट कोई अगर ऑब्जेक्ट जो है ऐसे रोटेट कर रही है विथ ओमेगा वेलोसिटी, व्हाट इज द ट्रांसलेशनल वेलोसिटी एंड रिलेशनशिप विथ दिस V. ठीक है. So the relationship between V and omega for without slipping condition is V is equal to R omega. Now if you do a time derivative, then automatically you end up getting what? Acceleration is equal to R alpha, or alpha is equal to A upon R. ठीक है. So this is the condition that we have. So let us put all of these values here. So let us use this also here, and then we will put it back here in this original equation. So in our original equation, you have mg sine theta minus f is equal to half mr alpha, which we came from the relationship between friction and rotation, is equal to ma, and then I'm going to again use mg sine theta minus half mr alpha. So alpha is equal to a upon r, which is coming from without slipping condition, half mr. Alpha is equal to a upon r, so r and r gets cancelled, is equal to ma. M and m gets cancelled, so you have g sine theta minus a by 2 is equal to a, or g sine theta is equal to a plus a by 2 is a plus a by 2, 2 plus 1, 3 is equal to 3 upon 2a. So or a is equal to 2 upon 3 g sine theta is your answer. The answer is simple. However, it requires that you understand a few things. You understand where the forces are acting, how the forces are acting, what are the force equations along the y-axis and the x-axis, and then you understand the relationship between friction and rotation. You understand the expressions for torque, moment of inertia, angular acceleration. You understand the concept of slipping, without slipping or slipping. And when you apply all of these concepts, you come up with finally the linear acceleration, not the angular acceleration, but the linear acceleration of any kind of a disc or a wheel or a cylinder rolling down an inclined plane. All right. Any confusion or any doubt you have in this particular question? Any doubt, any query in this particular question? No? Can we move ahead to the next question then?
Yes sir.
Yeah?
Yes, sir.
All right. Let's move ahead to the next question. ठीक है. कुछ बच्चों को लग रहा होगा that these questions are very simple. They are. The only purpose that I have is just to sort of revise, like, the purpose of revision. That's all. To bring back into memory all these concepts. That's my objective here. And once I'm done with this objective, I'll straight away go to Lagrangian. Okay, so now let's look at the second question now, which is the pulley question related to pulley. All right. The second question, this is the first question that we had, question number 1, and now let's go to the second question, which is the Atwood machine or pulley mass system basically. Again, my objective is not to get the answers but to understand the concept behind solving problems like these. तो यहाँ पे क्या है, you have a pulley, you understand what a pulley is. 11-12 में भी इस तरह के क्वेश्चन आते थे. And the pulley is attached to some kind of a massless inextensible string that is wound over it, and there are two masses on each side. You have mass m1 and you have mass m2, and जो भी mass heavy है, let's suppose mass m1 is heavier, in that case it will start accelerating in some direction. All right, so let's suppose if mass m1 is heavy, then and if the string is inextensible, मतलब string का जो length है वो constant रहेगा, वो change नहीं होगा. In that case, both the masses are going to accelerate in the same manner, one downward, another forward or upward. All right. So massless pulley के लिए और massive pulley के लिए हम problem को कैसे solve कर सकते हैं, ठीक है? So again, the same concept I'm going to use that I've used in a previous question, I'm going to use here also. And the concept is first related to the forces. We want to see what are the forces balanced, imbalanced, वगैरह वगैरह. So can you tell me how many forces and which of the forces are involved in this particular problem? One by one. Which forces are there?
So weight is there.
Wait, just a moment.
Yes, sir.
Weight is there for both the masses, right? So you have m1g and then you have m2g, right? And
Tensor.
tension is also there, yes. So tension is a contact force, just like normal reaction. Whenever you have an object on some kind of a surface, then there is always a normal reaction to it. The normal reaction prevents the object from experiencing or motion due to gravity, right? If there was no normal reaction, the object should technically fall straight down, but it does not fall because there is a surface. So the surface is providing some kind of a normal reaction to it. So these kind of forces are known as contact forces. Okay, similarly, whenever some object is hanging from a thread or a string, then it is experiencing weight, but the motion is not happening due to the intermolecular attraction of the atoms in the string, which arises, which is also known as a contact force, and it is called as tension. So T1 or T2. So T1 and T2 prevents any kind of a motion that would have happened otherwise in its absence. So there are these two forces, T1, T2, M1G, M2G. That's it. And because of these two forces, some sort of an acceleration is happening. All right. So यहाँ पे x axis नहीं है, y axis नहीं है, यहाँ पे यही बस vertical axis है. But there are two masses and therefore we will have two equations of forces involved. Okay. So for हम A का point करेंगे, ठीक है? First we will do point A massless pulley के लिए. For M1, what is the force equation? M1G minus the tension is equal to M1A, because the net force is equal to M1A is the Newton's second law. Any kind of an imbalance force will result in some kind of an acceleration. So what is the imbalance in forces? M1G is greater than T1. अगर M1G greater than T1 नहीं होगा, T1 is greater than M1G, तो नीचे की तरफ एक्सेलरेट करेगा नहीं, ऊपर की तरफ करेगा. और अगर दोनों बराबर होगा तो कोई एक्सेलरेशन नहीं होगा, ठीक है? And for mass M2, you will have again F net is equal to M2A. दोनों के accelerations बराबर है, as I said, because the string is inextensible. So this is going to be what? T2 minus M2G is equal to M2A. These two are valid equations, yes? This is 1 and this is 2. Right. Now, let us add these two equations. Add 1 and 2, and I end up getting M1G minus T1 my plus T2 minus M2G is equal to M1A plus M2A. All right, now before we continue with this calculations, can somebody tell me what is going to happen to T1 and T2?
They both are equal.
They both are equal. Why? They are both equal, yes, but why? Can you tell me a reason?
अगर अगर वो दोनों इक्वल नहीं होंगे तो फिर उनकी स्ट्रिंग की लेंथ चेंज हो जाएगी, या मतलब
स्ट्रिंग की लेंथ चेंज हो जाएगी. हाँ, वो तो है नहीं पॉसिबल फिजिकली बिकॉज देयर इज एन
Yes, sir.
इनएक्सटेंसिबल स्ट्रिंग. और क्या अदर पॉसिबिलिटी अगर दोनों इक्वल नहीं होंगी तो? कि दोनों मासेस का एक्सेलरेशन अलग है, वो भी फिजिकली पॉसिबल नहीं है ना. सो फॉर द केस ऑफ मासलेस पुली, ड्यू टू न्यूटन्स थर्ड लॉ, T1 इज इक्वल टू T2, कि जो इस तरफ टेंशन है उस तरफ भी वही होगा. इट इज सिंपली अ रिजल्ट ऑफ न्यूटन्स थर्ड लॉ. एंड ऑल्सो फॉर द केस ऑफ मासलेस पुली. व्हाई मासलेस? बिकॉज द contribution of the inertia of the pulley, the inertia of the pulley is not contributing to the system's mass. The system has a certain mass and there is an inertia that is responsible for the motion that is happening. The inertia of the massless pulley is not contributing because it is a massless pulley. Massless pulley है तो उसका inertia contribute नहीं कर रहा, तो force equation में आएगा नहीं. So in that kind of a situation, T1 is equal to T2. So if T1 is equal to T2, so what do we do? So what we're going to do is we're going to subtract ना. It's better to subtract them. No, subtract करने की ज़रूरत नहीं, यहाँ पे तो cancel हो ही रहा है. So these two are getting cancelled. So that simply leads to M1 minus M2 G is equal to M1 plus M2A. All right. So this is nothing but A is equal to M1 minus M2 G upon M1 plus M2. Okay, so this is your answer for the acceleration that Deepak had obtained initially. Okay, quite simple, right? Extremely simple. However, this is only simple for the case of massless pulley. Okay, what if I have a massive pulley? What is going to change if I do the second case scenario for massive pulley? What is going to change in our calculations? Who can say? What specific thing is going to be different in the calculations if we have a massive pulley?
Sir, rotation will take place of pulley.
रोटेशन तो पहले भी हो रहा था. पहले भी तो रोटेशन हो रहा था. स्लाइडिंग मोशन नहीं था. विदाउट स्लिपिंग पहले से लिखा हुआ है यहाँ पे, विदाउट स्लिपिंग. सो रोटेशन पहले भी हो रहा था. अभी क्या डिफरेंस होगा? Anyone?
Inertia is not equal to
mass
zero.
वजह से gravity.
Inertia of the pulley is not equal to 0. Yes. What is the second answer? Someone said.
Sir, gravity on pulley. MPG.
Pulley is attached to the ceiling, so that would be taken care of by the ceiling के साथ जो contact force है.
Sir, T1 T2 equal नहीं होंगे.
Exactly. Very good. Exactly. T1 and T2 will not be equal. All right. For massive pulley, T1 is not equal to T2. Why? Because now when the pulley is massive, pulley has a contribution towards the inertia of the system. Pulley is also rotating. पहले भी rotate कर रहा था, but now it is rotating. And the rotation is happening because of why? इट इज़ हैपनिंग बिकॉज ऑफ अ डिफरेंस इन दीज फोर्सेस अराइजिंग आउट ऑफ इट. अगर आपके पास कोई एक लेट्स सपोज डिस्क है, ठीक है, अगर डिस्क में जो है ऐसे फोर्स लगता है, लेट्स सपोज डिस्क की जो रेडियस है वो r है एंड फोर्स लगता है F, तो टॉर्क कितना होगा उसमें? टॉर्क कितना होगा उसमें? RF. वेरी गुड, सिंपल क्वेश्चन है. अगर आपके पास ए सिमिलर डिस्क है और आपके पास जो है फोर्स लग रही है इस तरह से, यहाँ पे एक फोर्स लग रहा है और यहाँ पे एक फोर्स लग रहा है, तो इसमें टॉर्क कितना होगा? इसमें कितना होगा? इसमें कितना होगा? कम ऑन
सर 0.
वेरी गुड. अगर वेरी गुड, इट्स दिस इज सिंपल क्वेश्चन आई एम आस्किंग. आप कंफ्यूज क्यों हो रहे हो? अगर आपके पास ऐसा एक फोर्स है F और ऐसा एक फोर्स है F, तो इसमें टॉर्क कितना होगा?
सर 2RF.
वेरी गुड. और अगर आपके पास एक ऐसा सिस्टम है, ऑलराइट, जहाँ पे एक फोर्स F1 लग रहा है और दूसरा फोर्स F2 लग रहा है, इसमें टॉर्क कितना होगा?
F1 minus F2.
Yes, RF1 minus F2. Exactly the same scenario is happening here. यहाँ पे the torque is being created and an angular acceleration is happening, and that is happening as a result in the difference in the tensions of both the strings. अगर दोनों स्ट्रिंग का टेंशन बराबर होता तो ये रोटेशन होता ही नहीं. फर्स्ट केस में बराबर इसलिए है बिकॉज वो मासलेस है. मासलेस होने का मतलब है इट हैज़ ज़ीरो कॉन्ट्रीब्यूशन टुवर्ड्स द इनर्शिया. बट सेकेंड केस में ये हो नहीं सकता बिकॉज अगर दोनों बराबर होगा तो रोटेशन होगा ही नहीं. ठीक है. सो देयरफॉर इन आवर सेकेंड सिचुएशन द टॉर्क that is responsible for the rotation of the pulley is equal to R T1 minus T2. Yes. Yes.
Yes, sir.
ओके. सो जिस तरह से हमने ये प्रीवियस क्वेश्चन में क्या किया था, हमने एक एक्सप्रेशन लिया टॉर्क का RF, दूसरा हमने मोमेंट ऑफ इनर्शिया और एंगुलर एक्सेलरेशन के साथ रिलेशनशिप ऑब्टेन किया था. सेम चीज़ यहाँ पे भी करते हैं. ठीक है. सो R इंटू डिफरेंस इन दी फोर्सेज इन बोथ दीज टू points of contact is equal to the moment of inertia into angular acceleration. Yes. So what is R T1 minus T2? What is the moment of inertia of the pulley? If we consider the pulley to be a disk, the moment of inertia is half mp r square alpha. Okay. Or T1 minus T2 is equal to half mp r alpha. This is one concept. And for no slipping, what can we use? Which concept can we use? That V is equal to R omega. That means whatever the velocity of a point of contact is, okay, instantaneous velocity is related to the omega, and therefore the linear acceleration of any point of contact is related to the angular acceleration alpha. This is the angular acceleration alpha in this particular manner if there is no slipping happening. Slipping अगर होगा तो पुली को रोटेट करने की ज़रूरत ही नहीं है. Without rotation that this can take place. So if I use this here, then this simply becomes half mp r a upon r. R cancel, half mp a. Okay. So now let us use this equation again. ये जो इक्वेशन है हमारा, इसको दोबारा से हम यूज़ करते हैं. ठीक है. यहाँ पे दोबारा से यूज़ कर सकते हैं ना, बिकॉज यहाँ इससे पहले तक जो कॉन्सेप्ट है वो सेम है दोनों केसेस में. इससे पहले तक जो कॉन्सेप्ट है वो सेम है. दोबारा से अगर हम इसको यूज़ करेंगे, सो इफ़ वी ऐड बोथ दीज टू इक्वेशंस, m1g माइनस T1, m1g माइनस T1 प्लस T2 माइनस m2g is equal to m1a plus m2a, m1a plus m2a. सो यहाँ पे अगर हम सब्सटीट्यूट करते हैं इस एक्सप्रेशन को, इफ यू सब्सटीट्यूट दिस हियर, जस्ट अ मोमेंट, if you substitute this here, then I simply get m1g minus t1 minus t2 minus m2g is equal to m1 plus m2a, or I end up getting m1g minus t1 minus t2 is half mpa minus m2g is equal to m1 plus m2a, or m1 minus m2g is equal to m1 plus m2 plus mp upon 2a, or a is equal to m1 minus m2g divided by m1 plus m2 plus mp upon 2. This is your answer. ठीक है, दिस इज क्लियर, दिस इज योर आंसर. यहाँ पे mp को आप 0 रख देंगे तो आपका प्रीवियस आंसर आ जाएगा. mp को अगर 0 रख देंगे तो प्रीवियस आंसर आपका आ जाएगा. दिस इज द सोल्यूशन. एनी डाउट हियर? Any doubt at this particular point in this question or any query?
No, sir.
Can we move ahead to the next question?
Yes.
Yes? All right, let's move ahead to the next question, but just give me 2 minutes. I just got a call. Let me call back and I'll. Okay, all right. Let us come back to the next third question then. Okay, let me explain the third question. So the question was that there is some kind of a rod. Okay, there is some kind of a rod that is rotating with angular velocity omega with respect to the origin O. ठीक है, इस तरह का रोटेशन कर रहा है. Okay, with respect to the origin O, this rod is rotating with constant angular velocity. Now इस rod के ऊपर we have put a bead. Bead समझते हो ना, जैसे नेकलेस में छोटे छोटे वो होते हैं ना, बीड्स होते हैं ना, जिसको आप टू एंड फ्रो मूव कर सकते हैं. इट्स नॉट फिक्स्ड, इट कैन स्लाइड ऑन द वायर. सो द बीड कैन स्लाइड ऑन द वायर, इट कैन गो बैक एंड फोर्थ, आगे पीछे वो मूव कर सकता है. एंड द बीड हैज़ अ मास m. Okay, the bead can slide on the wire, it has a mass m. All right, it can slide on the wire, it has a mass m. And the contact between the bead and this rod is frictionless. There is no friction whatsoever between the bead and the wire. So what is the solution for the nature of motion of the bead? All right, what is the nature of motion of the bead and what is the mathematical solution for it? All right, so now because we are dealing with rotation, Which sort of a coordinate frame of reference would be best helpful for us to do the problem?
Spherical.
हाँ, पोलर ले सकते हैं बिकॉज यहाँ पे सिर्फ एक्स वाई अगर एक ही प्लेन में जो है रोटेशन हो रहा है, 3D स्पेस में रोटेशन नहीं हो रहा है, यहाँ पे सिर्फ 2D प्लेन में रोटेशन हो रहा है. सो इट इज़ बेस्ट टू लुक एट द न्यूटन्स इक्वेशंस इन अ पोलर कोऑर्डिनेट्स due to circular motion happening on a plane. It's best to analyze the Newton's laws in polar coordinates. राइट. नाउ द क्वेश्चन इज पोलर कोऑर्डिनेट्स में हम इसको एनालाइज करना चाहते हैं. तो पोलर कोऑर्डिनेट्स में न्यूटन लॉज मतलब क्या? न्यूटन सेकंड लॉ, राइट. सो एफ नेट इज इक्वल टू एम ए, मतलब वॉट एवर इज द फोर्स दैट द पार्टिकल इज एक्सपीरियंसिंग इज वॉट इज लीडिंग टू द एक्सेलरेशन. द एक्सेलरेशन इज बीइंग कॉज्ड बाय वॉट एवर द फोर्स द पार्टिकल इज एक्सपीरियंसिंग. नाउ अगर हम एक्स वाई एक्सिस में लिखते हैं तो हम इसको लिखते कैसे? हम इसको लिखते कि एफ एक्स कोई कंपोनेंट है, जैसे कि हमने यहाँ पे जो दो इक्वेशंस लिखी है, यहाँ पे एक नहीं, यहाँ पे इससे पहले वाले क्वेश्चन में एक एक्स एक्सिस के लिए लिख दिया एक इक्वेशन, एक दूसरे एक्सिस के लिए लिख दिया दूसरा इक्वेशन. सो दीज आर कंपोनेंट्स ऑफ द फोर्स अलोंग द एक्स एक्सिस और वाई एक्सिस, राइट. सो अगर मैं इसको वेक्टर फॉर्म में एक ही लाइन में लिखना चाहता हूँ, आई कैन सिंपली से दैट एफ एक्स कुछ हो गया I component, right, and Fy कुछ हो गया J component, right. It is leading to the acceleration. So the question is, if I do not want to use the xy axis, if I simply want to use the Fxi cap plus Fyj cap in terms of, let's suppose, Maxi cap plus Mayj cap, तो polar coordinates में accelerations को कैसे लिखते हैं? Polar coordinates मतलब आपका क्या हो गया? r theta. So what happens in एक्स वाई से अगर हम आर थीटा के फ्रेम ऑफ रेफरेंस में जाएंगे तो हम इसको कैसे लिखेंगे? Anybody remembers? Mechanics first year.
हेलो.
हाँ,
सर रेडियल कंपोनेंट तो आर डबल बार माइनस का बार स्क्वायर.
okay, this is the radial component of acceleration. And angular?
सर 2r डॉट थीटा डॉट प्लस में थीटा डबल डॉट डबल डेरिवेटिव.
ये
नहीं सर, प्लस में आता है शायद.
प्लस कहाँ से आता है? माइनस में आता है ना. ये तो कोरियोलिस कंपोनेंट माइनस में आता है ना. माइनस आर क्रॉस ओमेगा क्रॉस आर माइनस में आता है. सो दिस इज द एक्सेलरेशन इन पोलर कोऑर्डिनेट्स, है ना. ये माइनस में ही तो आता है, जहां तक मुझे मालूम है माइनस में आता है. दिस एक्सप्रेशन इज करेक्ट बेटा. डू यू रिमेंबर दिस एक्सप्रेशन नाउ? द रेस्ट ऑफ द स्टूडेंट्स.
सर ये प्लस आता है शायद. सर ये
प्लस आता है.
सर जहाँ तक मुझे याद है सर मैंने प्लस देखा था.
चलो देख लेते हैं. मेरे पास
सर ए थीटा में प्लस आएगा शायद.
एक
ए
सेकंड
थीटा
मैं चेक कर लेता हूँ. लेट मी चेक. maybe I have forgotten something. Where is acceleration? हाँ, ये प्लस है. सॉरी. All right, I'm so sorry. This is plus. You're right. Yes, this is plus. You're right, and I probably made a mistake. Yes, let me correct it. हो जाता है कभी कभी. Okay, so this is plus. Thank you for pointing it out. ठीक है, this is fine now. This is fine now.
Yes, sir.
All right.
Yes, sir.
So now, so this is nothing but a r cap plus a theta theta cap. So the point is, I can solve the Newton's second law either in xy coordinates or in r theta coordinates or in any other coordinate system. It's just that I have to write the components in that manner. So this is for xy coordinates. I can also solve in terms of fr r cap plus f theta theta cap is equal to ar m ar r cap plus m a theta theta cap. So which is equal to m r double dot minus r theta dot square r cap plus m r theta double dot plus 2 r dot theta cap. So यहाँ पे basically Fr is the force along the radial direction जिसका component है ये, and F theta is the force along the angular direction जिसका component है ये. ठीक है, so और Fr is equal to m r double dot minus r theta dot square and f theta is equal to m r theta double dot plus 2 r dot theta dot. ठीक है, जिस तरह से मैंने यहाँ पे x एक्सिस में एक इक्वेशन लिखी थी और y एक्सिस में एक इक्वेशन लिखी थी, सो उसी तरह से इन पोलर कोऑर्डिनेट्स आई राइट दिस इक्वेशन along radial axis and this is along angular axis. Okay, for the bead. Fine, this is clear till now. मैं चीज़ों को तो क्वेश्चन को सॉल्व करने के लिए जो है बहुत आसान है, लेकिन मैं थोड़ा चीज़ों को डिटेल में एक्सप्लेन कर रहा हूँ ताकि कम्स बैक टू योर मेमोरी. दैट्स ऑल. दिस इज क्लियर टिल नाउ. दीज टू इक्वेशंस आर क्लियर. Yes, no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right. Now, it is already given in the question that the angular velocity is a constant. Yes. It is already given in the question that given that angular velocity क्या होता है, theta dot is a constant. तो अगर theta dot constant है तो solution तो हमारे पास है ना, उसको solve करने की कोई ज़रूरत नहीं है. जो भी सोल्यूशन होगा इस इक्वेशन का, जो भी फोर्स होगा, इट शुड लीड टू थीटा डॉट इज इक्वल टू कांस्टेंट. दैट्स इट. एंड थीटा इज इक्वल टू सम कांस्टेंट मल्टीप्लाइड बाय टाइम. सो दैट इज ऑलरेडी गिवन टू अस. द क्वेश्चन इज ऑलरेडी टोल्ड अस दैट द एंगुलर वेलोसिटी इज अ कांस्टेंट. इफ द एंगुलर वेलोसिटी इज अ कांस्टेंट, जो ये इक्वेशन है इसका सोल्यूशन हमें क्या देगा, ये थीटा ही तो देगा ना. इसका सोल्यूशन हमें थीटा ही तो देगा. तो थीटा डॉट इज अ कांस्टेंट तो दिया हुआ है, तो थीटा इज नथिंग बट थीटा डॉट इनटू टाइम. The only thing that is not given to us is this. What is the radial motion? Radial motion क्या है हमें नहीं मालूम. नहीं मालूम. Angular motion हमें मालूम है, already given in the question. Radial motion हमें नहीं मालूम. So रेडियल मोशन को ही हमें सॉल्व करने की ज़रूरत है, एंगुलर मोशन को सॉल्व करने की ज़रूरत नहीं है. तो रेडियल मोशन को अगर हमें सॉल्व करना है तो कैन यू टेल मी व्हाट आर द फोर्सेस इन्वॉल्व्ड हियर इन द रेडियल डायरेक्शन. What are the forces involved here in the radial direction? Anyone? What are the forces involved here in the radial axis? Radial तो आप समझते हैं ना? Radial is this direction. This is r cap. Away from the origin, along a straight line. What are the forces involved here in the radial direction? Any guesses?
So centrifugal force.
Centrifugal force, yes, due to rotation, yes. But centrifugal force is a pseudo force, a fictitious force that arises out of this quantity, है ना? I am asking about this. What is the force as a result of interaction? Centrifugal force basically arises when you make a transformation from an inertial xy axis to a rotating, let's suppose, r theta axis. So it arises due to the mathematical equations. It looks like a force, it feels like a force, it acts like a force, but it is not a real force. It is a fictitious force. आपको तो मालूम है ना, मैकेनिक्स में पढ़ा होगा सेंट्रीफ्यूगल, कोरियोलिस, फिक्टिशियस, सूडो फोर्सेस पढ़ा है ना. तो सेंट्रीफ्यूगल इज अ फिक्टिशियस फोर्स, यू नो दिस, राइट?
Yes, sir.
It's not a real force. So I am asking, what is the real force involved here? Guess करके बता दो, कोई दिक्कत नहीं है.
Sir, centripetal is there because it's rotating, so probably
Centripetal
centripetal is a real.
force results, let's suppose, due to gravitational attraction, due to electrostatic attraction. यहाँ पे वैसा कुछ नहीं है, तो centripetal क्यों आएगा? Centripetal arises whenever central forces are there, like gravitational attraction, electrostatic attraction, but यहाँ पे तो नहीं है. अच्छा ये बताओ, फोर्सेस है कि नहीं है, ये बताओ मुझे, along the r axis, interacting force. फोर्सेस है कि नहीं है?
So probably R में नहीं है शायद.
नहीं है. You're correct. Maybe it felt like a trick question. I was asking which forces are there, but there are no forces along the r axis because it's frictionless. Yes, your guess is correct. It's a frictionless contact, so there are no forces along the r axis. No forces. No forces का मतलब क्या है? This is 0. Yes. This is clear to you guys. Along the radial axis, there are no forces except for the pseudo forces like centrifugal forces that arise as a result of the transformation equations जो हमने यहाँ पे put कर दिया है. But Fr is equal to 0. No friction, nothing. Is this okay, guys? Is this clear?
Yes, sir.
All right. So f थीटा का जो इक्वेशन है वो हमें सॉल्व करने की ज़रूरत नहीं, बिकॉज थीटा डॉट इज़ अ कांस्टेंट क्वेश्चन में दिया हुआ है. एफ आर का जो इक्वेशन है उसमें एफ आर जो है वो 0 है, बिकॉज नो फोर्सेज आर देयर अलोंग द रेडियल एक्सिस. सो द ओनली इक्वेशन दैट वी नीड टू सॉल्व इज एम आर डबल डॉट माइनस आर थीटा डॉट स्क्वायर is equal to 0. So this leads to r double dot minus r theta dot square is equal to 0, which leads to d2r upon dt2 minus theta dot क्या है is equal to omega square r is equal to 0. So I end up getting a second order differential equation. Anybody knows what is the solution of the second order differential equation?
So e raised to e raised to omega t,
Or
a e raised to omega t,
and there are two terms.
plus b e raised to minus omega t.
Yes, very good. So a e to the power omega t plus b e to the power minus omega t. This is the solution for this kind of a second order differential equation. Yes.
Yes.
All right. Now what is a, what is b? They are all dependent upon the initial constants that we have provided at time t is equal to 0. What are the values of, let's suppose, r and v? So let's suppose that at t is equal to 0, rt is equal to r naught, then r naught is equal to a e to the power 0 plus b e to the power 0 is equal to a plus b. ठीक है. And at t is equal to 0, if v t, which is equal to a omega e to the power omega t minus b omega e to the power minus omega t, this is equal to let's make it easier for us. Let's make it 0 initially. Okay, let's make it 0, easier for us. So if this is equal to V0 is equal to 0, then at time t is equal to 0, a omega minus b omega is equal to 0, or a minus b is equal to 0, or a is equal to b. Okay, so that means then a is equal to, using both these two, इसको और इसको यूज करके हम क्या लिख सकते हैं, दिस इज इक्वल टू आर नॉट बाई 2. यस, yes. So final solution is RT is equal to R naught upon 2 e to the power omega t plus e to the power minus omega t. This is a solution. What do you think? This is a solution, right?
Yes, sir.
Okay. Now can you tell me what is the characteristic? There are two functions here. One is the exponentially increasing, one is exponentially decreasing. Now what is the effect of this and what is the effect of this?
So because of the first, it exponentially increases. Because of the second, it exponentially decreases.
Okay. So this basically leads to bead going away from origin, right?
Yes, sir.
Going away from origin, and this leads to bead going towards origin, right?
Yes, sir.
Now can you tell me at which one of these quantities are going to dominate over the other for greater values of t?
Sir, the first term.
First term. So e omega t will dominate over e to the power minus omega t, this will tend to infinity and this will tend to 0, right? So the one that tends to infinity will easily dominate over the one that tends towards 0, right? So therefore, finally, what is the nature of the motion that is going to happen? The nature
It's basically exponential to higher values of t.
Yes, you will end up getting, so basically the angular velocity is a constant, the radius is increasing, so you will end up getting some kind of a spiral trajectory like this. मतलब कि क्या हो रहा है कि एंगुलर वेलोसिटी जो है वो कांस्टेंट रहेगा, लेकिन जो रेडियस इंक्रीज है वो एक्सपोनेंशियल होगा. मतलब the angular velocity of the mass is a constant, but the radial velocity of the mass will have an exponential term, or the radial displacement will have an exponential term. So you'll end up getting some kind of a spiral trajectory, which somebody told me yesterday, I think. So the answer is spiral, but यहाँ पे जो spiral होगा, it will be created by angular displacement, which is of constant angular velocity, and radial displacement, which is exponentially increasing. Is this clear? Any doubts you have in this question?
Sir, in this case, I mean the radial direction is increasing,
Yes.
even when there is no if we see this motion from, let's say, an inertial frame where all the pseudo forces cannot be considered, they are non-existent. Then from that frame we see that the radial force is 0, as you have put in the equation, right? So
Wait. Can you repeat the question, please?
Yes, sir. Sir, in this system, if we view the system from an inertial frame,
Inertial, as in let's suppose there is a person with respect to which the rod is rotating, right?
yes,
But
which
this
is not
the
sitting on the rod. Basically.
So the spiral trajectory is with respect to that inertial frame only, na?
Yes, sir. So
With respect to a rotating
yes, sir.
observer, it will be a straight line.
Yes, sir. Yes, sir. My question is, when a person who is in the inertial frame looks at this, he sees that there is a spiral trajectory, which basically means that the radius is increasing.
Yes.
That it's going radially outward. But the net force for him is 0. Net radial force is 0. So this is a little counterintuitive, because I got this because some days ago I was doing this question where if there is a, let's say, a rotating plate, and if on that rotating plate you put an object, it seems to come out radially outwards. But from an inertial frame, you cannot account for that radial motion because there are no radial forces from the inertial frame. So, well, how does this?
The radial forces arise due to contact with the plate.
Okay.
So if the in your question, if the plate is rotating, but on top of the plate there is an object, but there is completely zero contact between them, then there is not going to be any kind of a force on the particle, right?
Yes.
Only because it is in contact with the plate, it experiences a centrifugal force.
Yes.
Just like
But
let's
from the
suppose,
inertial, yes, yes.
just like
Yeah.
let's suppose you are sitting in a merry-go-round. If the merry-go-round is rotating at very high velocities, you'll experience forces.
Yes, sir.
Now, why does this centrifugal force arise? That is your question, right?
No, so my question is, in the rotating frame, it's obvious that it's the centrifugal force that is causing the radial motion,
Yes.
right? But from the point of view of an inertial observer,
Huh.
there is no such force, right? So, and you cannot like change frames. But I'm just saying that the observer is in the inertial frame, and
Yeah.
he observes that the bead is slipping away radially outwards.
Uh-huh.
So that seems a little, I mean, because he cannot account for that radial motion because there is no radial force.
That
And
can be accounted for by Newton's first law. Can I give you an example, a separate example?
Sure.
So let's suppose, have you traveled in hilly areas on a bus?
When I was really small, yeah, so I don't probably remember,
So,
but yes.
maybe you remember this, that when the bus goes around in some kind of a very curved path, all right, if the bus is traveling in a curved path, and let's suppose you're sitting on the seat, then do you experience some kind of a force outwards?
Yes, sir.
Even if you're not in a hilly area, if you're in a city, some of these bus drivers, they drive so recklessly around turns that if it makes a sharp turn, you experience a force sliding away in the radial direction. Yes or no?
Yes, sir.
Now, for this guy, it is a centrifugal force, yes?
Yes, sir.
But for another person who is, as you are saying, is an inertial observer, for him, what is this force? Are you understanding the question?
Sir, just inertia.
Yes.
Sir, it's just inertia for
Exactly. It is just inertia tending to go in a straight line. That is Newton's first law. But because of contact, he is curving, but the inertia is trying to go in a this direction. So when he reaches here, when the bus goes to a particular point here, so this inertia is tending towards this manner, but his experience will be along the radial direction always. So his experience is a force along the radial direction, but for an inertial observer, it is just inertia acting when your surface on which you are in contact with is going in a rotating or something like that.
Acha, okay, I got it. Same scenario with the bead. This bead's inertia basically makes it look like it's going radially outwards
Bead
when
is
the
in
actual
contact-
surface on which it's standing.
Yes.
Yeah.
Bead is in contact with the rod. So because the rod is rotating, it is experiencing a force radially outwards. But these forces, which the person in the rotating frame of reference experiences to be radially outwards, are merely the result of inertia from the perspective of an inertial observer.
Okay, so basically, in the plate example, when you put a bead on the plate, so the plate is slipping from below, but the bead is trying to stay there. But the plate is slipping from below, so that is why bead kind of comes out. It looks as if it's coming out because of the inertia, right?
Actually, in the case of the plate, what is happening is that the bead must also be rotating. But how will the bead be rotating? It will only be rotating due to contact with the plate.
Yes.
And because of that contact, it starts rotating. And when it starts rotating, inertia acts upon it in the tangential direction, which from the perspective of the mass looks like it is in the radial direction.
Oh, so basically from the inertia, so from the point of view of an inertial observer, there is no radial direction. It's just the tangential direction, which what I actually thought initially, that there should be a tangential direction,
Yes.
but it just looks like a radial direction. Okay.
From this person's perspective, it is a radial direction. Even he can think of radial direction, but from his perspective, the inertia is in the tangential direction.
Yes. So it basically flies the bead off in the tangential direction, but for an observer who's in the inertial frame, it is the tangential direction. But since the plate is moving, it kind of looks like it's radial.
Because
So
it's in
like
contact
basically
with the
and
plate.
yes,
It's in
because
contact
yeah,
with the plate.
if it's not in contact, then it will just stay there from the
Yeah,
inertial
it will
point of
not
view,
even
right?
move. Right, it will not even
Yes.
move.
Yeah. I got it. Thank you. Got it.
Okay. Now these questions are basically arise in Coriolis Forces chapter. Now they are very interesting. Now what happens when winds, and when the earth is rotating, the same thing is happening now. If like, let's suppose we are in India, right? If Australia wants to send a missile to India, they cannot do it straight. Because of Earth's rotation, it will experience forces, Coriolis forces, centrifugal forces, etc. You have winds, you have all these hurricanes and all these things that are happening in certain parts but not happening in other parts. The Earth's rotation plays a role. So it's a very interesting topic, Coriolis forces and all these things, centrifugal forces. All right. Now I have a particular problem that's actually given in the syllabus. So therefore this problem is very, very important. The syllabus has specially mentioned this particular problem, and the problem is charge particle and the motion of a charge particle experiencing some electric or magnetic field. Charge particle or motion of a charge particle in the presence of E and B. So we will do 4 cases. So let me demonstrate the 4 cases. Okay, the first case is when electric field is parallel to the magnetic field. Okay, you have electric field and you have magnetic field. So electric field and you have magnetic field. So this is E and this is B, and E is parallel to B is parallel to the velocity of the particle. So particle is, let's suppose, moving. Particle is moving in this direction with a velocity v0. What is going to be the nature of trajectory in this particular situation? First case, case 1. Okay, now case number 2. Okay, case number 2 is when there is no electric field, when there is only magnetic field. When there is only magnetic field and the magnetic field is perpendicular to the velocity. V0, and this is B. So V0 or V initially is perpendicular to B. This is case number 2. The third case is if both electric field and magnetic field are parallel, if both electric field, sorry, and magnetic field are parallel to the particle that is in motion. So you have E parallel to B perpendicular to V. Okay, case 3. Case 3. And lastly, you have the electric field and the magnetic field. You have the magnetic field and you have the electric field. क्या हो गया मेरा पे? Perpendicular to each other and also perpendicular to this thing. So electric field is in this direction and magnetic field is in this direction. So you have B, you have E, and E is perpendicular to B is perpendicular to V. This is case number 3. Sorry, case number 4. Okay, here you have B. Okay, are you able to visualize these 4 scenarios? First case, both electric field and magnetic field are parallel to each other and particles' initial motion is also parallel to them. Second case, magnetic field is perpendicular to the particles' initial motion. Third case, both electric and magnetic field are parallel to each other, but particles' motion is perpendicular to them. Fourth case, electric field is perpendicular to the magnetic field, which is also perpendicular to the initial velocity. Are you able to visualize these scenarios? Are you there?
Yes, sir.
Yes, sir.
Okay, so the obvious question is going to be, what are the nature of trajectories? What do you think is the nature of trajectory for all these cases? So एक एक करके शुरू करते हैं. First case में nature of trajectory क्या होना चाहिए? First case number 1.
Straight line.
A straight line.
Straight
Alright.
line.
Any other option? You're sure it's straight line?
Yes.
Yes, sir. It's either parallel or anti-parallel.
All right. Anybody else thinks it's not a straight line? It's something else? All if you agree that it's a straight line, right? Okay, let's go
Yes,
to
sir.
case number 2. What do you think should be the nature of the trajectory? Case number 2. What possible trajectory the particle will have?
It's a circular path.
Circular path. One option. Any other?
Helix.
Helix. Any other option? You think that the trajectory may be either circular or helix or anything else? Just two options, circular and helix, right? What about case number 3? What do you think is a possible trajectory in case number 3?
Circular path.
Case number
V is
3.
perpendicular to.
Case number 3, circular path. Okay. Or anyone else thinks it's not circular, it's something else?
Sir, spiral.
Spiral like this.
Yes.
Okay. Spiral. Anyone thinks it's something else?
सर केस नंबर 2 में
हाँ.
अगर एक बार उसकी डायरेक्शन फिर पैरेलल हो गई मैग्नेटिक फील्ड के, तो फिर तो वी क्रॉस बी 0 हो जाएगा, तो फिर उसके बाद उसके ऊपर कोई फोर्स नहीं रहेगा।
तो आपको क्या लगता है क्या ट्रैजेक्टरी होना चाहिए?
सर मतलब पहले तो कर्व लेकिन फिर स्ट्रेट लाइन हो जाएगा, स्ट्रेट लाइन पर अप्रोच करेगी।
Initially curve becomes straight line later at time infinity, है ना?
Sir, yes sir.
Yes.
Sir, third wale, second one. So I confused second and third. I thought it was going like first, second, third, fourth. So second will be so circular. Second will be circular, and the third will be it'll be a helical shape because
Helix.
there'll be some yes. Yeah.
Okay, fine. I'm not telling you the answers right now, okay? We will solve these questions in detail. I'm just asking you, what do you think before you even start solving them? What does your intuition tell you? Anybody else thinks it's either going to be something else other than a helix or a spiral in case number 3? Case number 3, anyone thinks it's going to be something other than helix or spiral? No. What about case number 4? What do you think is the trajectory in case number 4?
Cycloid.
Cycloid, okay. Any other trajectories out there? Harshita, what do you think? Akash, what do you think? Is cycloid going to be the answer or maybe something else?
सोच रहा हूँ।
Okay.
तो सर केस नंबर 2 में
हाँ.
वो मैग्नेटिक फील्ड की डायरेक्शन नहीं चेंज होगी ना, मतलब वो ऐसा तो नहीं है कि वो हमेशा परपेंडिकुलर रहेगा।
वो कांस्टेंट है।
ठीक है।
केस नंबर 3 में आपने नहीं बताया क्या होगा?
सर
केस नंबर 3 में क्या हो सकता है? केस नंबर 4, एनीवन एल्स? केस नंबर 1, 2, 3, 4, 1 में स्ट्रेट लाइन, 1 ऑप्शन. केस 2 में सर्कुलर पाथ, हेलिक्स, कर्व, स्ट्रेट लाइन, 3 ऑप्शंस. केस नंबर 3 में हेलिक्स, स्पाइरल, 2 ऑप्शंस. केस नंबर 4 में साइक्लॉइड. एनीवन वांट्स टू ऐड एनी काइंड ऑफ?
सर फोर्थ में स्पाइरल होना चाहिए।
स्पाइरल, ओके स्पाइरल, ठीक है. टेल मी योर आइडियाज, गेसेस, ताकि हम करेंगे तो थोड़ी सी क्लैरिटी आएगी ना. गेस करने में कोई देयर इज नो हार्म इन इट गेसिंग. व्हाट ट्रैजेक्टरीज यू फील will be the result of these systems. Okay, case number 1, maybe straight line, maybe something else, I don't know. Case number 2, maybe circular path, maybe helix, maybe a curve or tending to a straight line, I don't know, we'll have to check. Case number 3, maybe a helix, maybe a spiral, I don't know. Case number 4, cycloid or spiral or something else, I do not know. So these are the options that you have given me. So what we will do is we will solve these questions one by one in a detailed fashion and look at the nature of their trajectories using Newton's second law, of course. And when electric fields and magnetic fields interact with a charge particle, so this is a charge particle, okay, then what is the force law we use?
Lorentz force law.
Lorentz force law. So we will use Newton's second law as well as Lorentz force law to study these four systems in detail. So time. So it's almost 2:30 now. I think I'll do this in detail in one singular class. थोड़ा सा हमें detail में discuss करना पड़ेगा. तो probably in the next class I will approach these problems. तब तक you can think about it. If you feel that the trajectories might be something else, if there is any other possibility of any other trajectory, think about it. In the next class we'll solve all four cases and see which options match. Yes.
इनको विजुअलाइज एक दूसरे तरीके से किया जा सकता है कि
कैसे?
जैसे वो हम प्लेन सेम प्लेन में सारे कंसीडर कर रहे हैं, फर्स्ट सेकंड थर्ड केसेस, तो हम इनको इस तरह से देखते हैं कि इनवर्ड और आउटवर्ड अगर हम देखें तो हमें उस तरह से ज़्यादा क्लियर होता है राइट हैंड थंब रूल से.
ओके लेकिन मैग्नेटिक फील्ड और इलेक्ट्रिक फील्ड का जो इफेक्ट है चार्ज पार्टिकल का वो अलग है ना. राइट हैंड थंब रूल सिर्फ मैग्नेटिक फील्ड के लिए वर्क करता है, इलेक्ट्रिक फील्ड के लिए नहीं है. तो दोनों की कॉम्बिनेशन से क्या होने
तो
वाला
जैसे
है?
तो नहीं, जैसे अब केस 2 में राइट हैंड थंब रूल से अब मेरे को लग रहा है सर्कुलर ही होना चाहिए सर.
अच्छा, तुमने तो कहा था इनिशियली कर्व होगा फिर स्ट्रेट लाइन हो जाएगी.
नहीं सर, अब राइट हैंड थंब रूल से
अच्छा, आपको लगता है कि सर्कुलर होना चाहिए.
अब सर्कुलर लग रहा है.
अच्छा, और बाकी केसेस में?
बाकी में फर्स्ट में तो सर स्ट्रेट लाइन ही लग रहा है.
ओके.
और थर्ड और फोर्थ का भी श्योर नहीं है सर.
ऑलराइट, ठीक है. तो आप इसके बारे में थोड़ा सा सोचिए. ऑलराइट, वी विल डू द प्रॉब्लम्स मैथमेटिकली इन द नेक्स्ट क्लास. ठीक है. ठीक है गाइस, आज के लिए फिर मैं रैप अप करता हूँ. आई एम लीविंग इट हियर एंड आई विल कंटिन्यू इट फ्रॉम द नेक्स्ट क्लास. ऑलराइट. Yes, Sunandan. Yes, Sunandan, you were saying something?
No, sir. I was just saying bye. Thank you.
All right, okay. ठीक है, guys. Have a nice day then. I'm closing the class. All right. Have a nice day, guys.